Hey guys, it's your favorite TA here. Hopefully, if you're watching this, you know by now that this week in lab we are going to be doing paper chromatography. There are actually several different types of chromatography, but they all serve the same purpose, and that would be to separate things out from a mixture. There are also a lot of different aspects to chromatography, things that, explain how it works. But I'm not going to talk about that in this video because I have so many other things to discuss. So make sure you read the theory section of this experiment in your lab manual. You will probably need it for your pre-lab assignment anyway, but it would give you a better understanding of the experiment in general. This lab is actually pretty cool and pretty fun, but it can be tedious and time consuming. We know that from experience, so believe me when I tell you. But the purpose of me doing this video for you guys is to teach you some skills that you may or may not have, but you definitely need to get this experiment done. But also to give you tips, tricks, hints, as to how to go about this experiment, and hopefully you guys will be more efficient at it, and hopefully I will have answered a lot of questions that you might would have had if you had come into the lab without this video, and maybe we will get out of lab a little bit faster than we might expect. So I'm going to go through basically every step of this experiment with you guys, and hopefully it won't take forever. Yay. So the first thing that I'm going to tell you guys that we have changed about this experiment. Normally, it would just be you and your partner going through the whole thing, but we have changed that just a tad. So you have two parts to your procedure. One is labeled extraction of the dyes, the other is labeled chromatographic separation. For extraction of the dyes, so the first 13 steps, you guys are actually going to be working with the group that is next to you. Okay, so the middle of the bench will have everything that you and the group next to you need to share, and then your station will have everything that is just for you and your partner to do the last 6 steps. Okay, so every group will do its own chromatography, but you will be sharing your dyes with the group next to you. All right, so that is the first major change. In the middle, like I said, you guys will have everything that you need. So you should have a bag full of your materials for both groups, or just tools or instruments that you need for both groups to share. And then, of course, your chromatography materials will be at your own station. So let's get started with step 1. So it tells you to begin a boiling water bath by heating a 400 ml beaker of tap water on a hot plate. The beaker, the hot plate, the water should all already be there. Your TA might start the boiling water bath for you while you guys are taking the quiz, but if they don't, just come in, flip the switch, and then start letting it heat up. Step 2 tells you to get 6 3-centimeter strips of woolen yarn. These have already been cut for you. You're welcome. And they will be in your plastic bag. There will be more things in this bag than just what's in here now, but you can see that the yarn is already in there, and these have been cut to the right size. It also tells you to place the yarn in a large test tube. We actually have 3 sets of test tubes for you guys, and there's one large set, but there will actually be one test tube out of the 7 that is even larger than the rest, and that's going to be the one that you're going to put all 6 pieces into. Do not put one piece of yarn into 6 different test tubes and then try to heat it. You can put all of them in one test tube. Okay, and then add enough 5% acetic acid solution to cover the strips of yarn. So you can see here that I have my strips of yarn covered completely. When you first put them in, you might have to use your glass stirring rod to push them to the bottom. So this is what the glass stirring rod looks like, right? And so you would just put it in and kind of push that yarn towards the bottom. And if your yarn doesn't mind it, when you put a certain amount of acid into the test tube, your yarn might start to float, and so you'll have some pieces of yarn that are dry sticking out of the acid. Don't keep adding more acid, it's just going to keep floating higher up the test tube. So instead of adding more acid, just use your glass stirring rod to push the dry ends of the yarn into the acid itself. Okay, and then step 3 tells you to heat the test tube in the boiling water bath for 4 to 5 minutes. So you're going to take a test tube holder that should be near the hot plate. It's going to look like this, and these are super easy to use. You're just going to squeeze the sides and it should open, and then you're going to put the test tube inside the test tube holder towards the top, right, because you're going to put the bottom in the hot water bath, and then you're just going to set it into the 400 ml beaker. Okay, so in step 4, it tells you to cool to room temperature, so you're just going to take out the test tube with the yarn in it and put it back in your test tube rack and then allow it to cool. And it also tells you to remove the yarn from the test tube with tweezers, but we're not going to do that step until step 9 actually, because if we took the yarn out now where we'd put it, like a paper towel or something, that would be a bit weird. So it's actually going to take you a little bit for this test tube to cool anyway, so just leave them in there for now until we get to step 9 and actually need the yarn. So if we move to step 5, it just tells you to discard the acid. That's what the yarn was covered in. So when you get to that point in step 9 where you've taken the yarn out, then yes, go ahead and pour that acetic acid down the sink. Step 6 tells you to place each colored M&M into a separate test tube. Yes, you are working with M&Ms. Please do not eat them. Trust me, you don't want any of that. So don't eat the M&Ms, okay? And it also tells you to carefully label each tube as to what color M&M is in there. So let me show you the test tube rack. So this is my large set of test tubes, and these are the ones you'll be starting with. So except for this one, I forgot to label it with an R for red. But you can see that I have one of each color M&M in a test tube by itself, and then I've labeled my test tube, so this would be red, orange, yellow, green, blue, and brown. I did BR for brown, okay, so you can distinguish. But anyway, so it also tells you to add enough 5% acetic acid to each test tube to cover the candy. So we'll discuss this later on, but a very important part of this experiment is to have concentrated solutions. So the part where it says to cover the candies, you only want enough solution in that test tube to cover the candy. You don't want an excessive amount. So I'll actually show you what that should look like. Give me just a second. Okay. So I'm using the red M&M, and as you can see, the meniscus of the liquid is just barely touching the top. And when it comes to the acetic acid, we could actually, if it wasn't completely covered, we could agitate it a little and that acid would go over the top of it. So again, just try to put the smallest amount that you can just to cover that candy. Step 7 tells you to heat each test tube in the boiling water bath to help you dissolve the outside candy coating. We are actually not going to do that. Do not put the candy covered in acetic acid in the hot water bath. The acetic acid is more than capable of taking off the candy coating without heat. So mark that part out on step 7. You're just going to let the acetic acid eat away at the candy coating. It says once the candy coating has been dissolved, you would remove those from the test tube. So again, we're not doing that part on step 7, except for dissolving the candy coating. So let me show you what it should look like. So this was a red M&M, but you can see now that all the candy coating has been taken off, and this is just the chocolate left over. Okay. When it tells you in all capital letters to only dissolve the outside candy coating, that's referring to the fact that we don't want any chocolate in our in the solution that we get off from that. So this is what mine look like. I didn't use acid, I'm using water just because I wanted you guys to see it better. But you can tell that I don't have any brown coloring in the solution, so that means that I did a good job in not getting any chocolate into my solution. So if you start to see some of the chocolate break off into your solution, it has definitely been in there too long. So make sure you carefully try to go ahead and get the solution off of the chocolate that's still sitting in the test tube into the new test tube, which is what we're doing in step 8. So the clean set of labeled test tubes is where you're going to use your first set of small test tubes. So you will have a test tube rack like this with 2 sets of small test tubes. So this is the solution that I poured off of my red M&M that was covered in acid. So in step 8, when it says to decant each solution off the candy into the new test tubes, decant just means to pour solution off from. So I transferred the solution from my large test tube without the candy into my small test tube, and you're going to do that for all 6 colors. Step 9, this is where we're going to use the yarn that we took out of the hot water bath in step 4. So it tells you to add a piece of woolen yarn to the solution in each test tube. Now, back in step 4, I told you to remove the yarn using tweezers. I'm sure you might have recognized that these are very large test tubes, and these are how big the tweezers are. It's pretty obvious that these tweezers are not going to fit in the test tube. So a good way to do this, and this will actually be true every time we need to move yarn out of one test tube into another. So what you're going to do is take your stirring rod. We're going to go down one side of the tube with the stirring rod, and I'm going to trap the yarn against the other side and pull upwards. And you can see that I actually got all 6 pieces towards the end of the test tube, but I only need 1 per small test tube. So I'm going to take my tweezers and just grab 1 piece. And you see I got 1 piece out. And then I'm going to take that one, and then I'm going to put it into my solution. And you're going to do that for every color as well. Now, because the yarn is wet, it will probably stick to the side, although this one's kind of sliding down a little bit. But if it doesn't go all the way down, just rinse off your stirring rod with distilled water. This is distilled water, in case you guys didn't know that from last week. And then push that yarn down into the solution, just like that. Okay. All right. So then once you have a piece of yarn in each of the colored solutions, you're going to put the test tubes in the boiling water bath for 5 minutes. You can do this all at one time if you would like. So I'm going to show you. As you can see, I have managed to fit multiple test tubes in a 400 ml beaker, and these are actually the large test tubes. So you could most definitely fit all 6 small test tubes in here, and I do recommend leaving the test tube holders on. It will help keep the test tubes upright, but since they are so small, you might even need to hold them. You don't want the water from the hot water bath getting in the test tube, so just be careful of that. But you are more than welcome to do all 6 test tubes at one time for this step. Now the end of step 9, where it tells you to wash the first set of test tubes so that they're ready for step 11, you don't have to wash anything at this point. You have 3 sets of test tubes, so we're actually going to use another small set of test tubes for step 11 as opposed to the large test tubes. So step 10 tells you to remove the yarn with a pair of tweezers and to rinse it with a small amount of water. We are not going to rinse the yarn with a small amount of water. I will show you. So once you get the yarn out, so again, remember I told you every time we take yarn out, we're going to use the stirring rod to bring it to the end. So I go down one side, trap against the other, and pull it towards the end. And then I can easily grab it with my tweezers. And as you can see, my yarn is no longer white. It's like pretty pinkish. But mine is more vibrant than what y'all are going to see because I didn't use acid like you guys are going to use. So this is actually pretty vibrant. What it will really look like is a bit more pale. You'll see more of the white color that the yarn was originally. And if we were to rinse it with water, the pressure from the sink and from your distilled water bottle will be too much, and we will actually lose a majority of the dye out of that yarn. And because we want y'all to get good results, we don't want you guys to rinse it. So mark out that second part of step 10. For step 11, tells you to place each dyed yarn into a clean set of labeled test tubes. Again, one for each color candy. So this is where your second set of test tubes is going to come in handy. So you're going to grab one, and you're going to take your dyed yarn and you're going to put it in. And then, of course, it's sticking to the side, right? So we're going to push it down to the bottom. And this step is actually where the most important part is when I talked earlier about keeping a concentrated solution, because this is where you're going to get your dye from for your chromatography. So when you are adding 1 molar ammonia here, again, you only want enough to cover the yarn. So I did my best to push the yarn into a small space. And so when I add the ammonia, I am only putting enough to cover that yarn. So you can, if you can see clearly enough, the meniscus is just over wherever the highest point that the yarn is sitting in the test tube. And I know that it tells you approximately 1 mil, but I don't recommend measuring out a whole mil and then dropping it in there at once. Take the plastic pipette that is with the 1 molar ammonia bottle and fill it up, and then only squeeze enough in there to cover just the top of the yarn so that you don't have an excessive amount. Okay. So step 12 tells you to heat those tubes with the yarn and the ammonia in a boiling water bath for 5 minutes and stir occasionally to make sure that the dye gets released. An important note about this, when you are using your stirring rod, whether it's to push the yarn down that has dye or to stir any of these solutions in the boiling water bath, make sure that you are rinsing your stirring rod with distilled water between each dye. Otherwise, you will cross-contaminate colors and that will ruin your results at the end. It's very, very important, so make a note of that. And then the last step for the extraction is after 5 minutes, remove the test tubes from the water bath and place in your test tube rack. So that's going to be letting them cool while you set up everything for chromatography. So actually, while it's in the water bath for those 5 minutes, you can go ahead and start setting up your chromatography paper, drawing the lines, which is going to be step 1. Just make sure you set a timer and don't forget to take your yarn and ammonia solutions out of the hot water bath. Okay, so now that that's done, you are no longer working with the group next to you. It is just you and your partner doing your own chromatography. So step 1 for the chromatographic separation. So your chromatography paper is going to be this rectangular sheet here, and it tells you to draw a straight line across 1 centimeter from the bottom. So this is about 1 centimeter. I labeled it here for you guys, and I drew just a straight line all the way across. And then it tells you to mark and label with a pencil. So yes, I did mine in pen because otherwise you guys wouldn't be able to see it right now, but it is super important that you use pencil. I would tell you why, but it's a question in your pre-lab and I'm not going to give you the answer, so sorry about that. But anyway, make sure you're using pencil and not pen like I have shown here. Okay, so a spot for each colored candy and for tartrazine. So tartrazine is our yellow dye number 5, which in our scenario that we've been given, our friend cannot have. So we are actually going to have 7 spots that we are going to put on our chromatography paper, the 6 from the M&M and then 1 for tartrazine. So you can see that you need to leave a little bit of space from the edge of the paper. The spot will run off the paper, or since we're going to have it in a circle, it might spread to this side of the paper. So I left about 1.5 centimeters from the left edge when I started my first marking, and then between every color I did about 2 centimeters, and I'll label that for you guys here. So that is the suggested spacing, 2 centimeters between every colored spot, okay? And then later on, it will tell you that your solvent needs to reach about 1.5 centimeters from the top. So before we get to the part where we staple this into cylinder form, I went ahead and made 3 short pencil markings at the ends and the middle of the top of the chromatography paper, about 1.5 centimeters from the top. So that way, when it is in cylinder form and it is running, I can see from any side of the paper when that solvent has reached 1.5 centimeters from the top. So I would recommend that you guys do that too, so you're not guessing. Okay, so step 2 tells you to use a capillary tube to place a small spot of each concentrated dye solution and the tartrazine solution on the pencil line. And it also tells you in parentheses that you may want to practice on a piece of filter paper. So let me do a quick intro for you guys on how to use our capillary tubes. So this is what the filter paper will look like. It's just a circle here. Okay. The reason we are practicing on filter paper is because the chromatography paper is quite expensive. So every group is only going to get one piece. And if you need another piece after that, it is going to cost you 1 point on your experiment, because we are doing everything we can to make sure that y'all's chromatography doesn't get messed up, okay? So, all right, filter paper. Our capillary tubes look like this. They are not typical capillary tubes that we have worked with. These don't have the pointed end, but I do like these. They are much larger, much easier for you guys to control, which is great if you guys are just starting out using capillary tubes. But the way to use these, there's about 2 things you need to know about these capillary tubes. The first one is that you need to be quick. The longer you let the capillary tube touch the paper, the larger the spot will be. And once you're starting to practice, you will notice just how quickly that spot grows. The other thing, these capillary tubes in particular, not the common ones, they are easier to control when you take your index finger and hold the end. Okay, so if I were going to get dye out, I would just tilt my tube a little bit and try to get my capillary tube to touch. And so once it touches that liquid, it would draw it up. But I already have one, so I'm going to get that one instead. So then this would be one that has liquid drawn up into it. But when it comes to practicing, since you guys only have a limited amount of dye solution, I would recommend using the tartrazine, because we make that for you guys and we have a much larger amount of it. Okay, so this is what your tartrazine bottle is going to look like, and you can tell that it is a very bright yellow. They have their own capillary tubes. Okay, so I'll show you the difference between having your index finger on the end and just trying to do it just brute force. So without my index finger on the end, these are how large and irregular the spots turned out to be, right? But when I put my index finger on the end, I can control the spot much easier, and you see that all of these here are fairly uniform. They're all about the same size. They don't spread out too far, and they're actually a good size for you guys to put on your chromatography paper. If you are struggling with this, you and your partner both need to try to practice with this so you both get the skill in. But if you're having a hard time, ask your professor or your TA to come help you, and we will most definitely help you. So that's just a quick intro on how to use the capillary tubes. When it comes to spotting your chromatography paper, I kind of did a drawing, but I'm sorry, I'm not an artist. So if this is my chromatography paper, then what I would suggest doing to make this efficient, it tells you that you may need to spot 3 or 4 times, and you most definitely will, because your solutions will be fairly light. What I recommend is go ahead and getting all of your capillary tubes for your colors, and I would lay my chromatography paper flat on the bench, and then go ahead and fill up all my capillary tubes with some of the dye from the test tube, and then I would lay them in line with their corresponding color. So if this is where my red is on my chromatography paper, then I want my capillary tube in line with my red crosshair. And so you can see that where the crosshairs would be, where I made my 2 centimeter markings, where that meets the pencil line that I made, that's where I'm going to put my spot. And they're not going to be very big. The bigger you make them, the more that they might run into another large spot. And again, we don't want to cross colors over each other. So yours are not going to look this dark. I did this with pen, so don't expect them to look like this. They will be pretty faint. But if you are questioning if your spot is concentrated enough, then by all means ask your professor or ask your TA, and we will let you know if you need to spot some more times or if your solution is just not concentrated enough to be able to make it any darker, and then we'll have to help you find your spots after it's been run. So it also tells you that when you are spotting, you need to do a spot, let it dry, and then put more spot before you put more spots on top. Well, it would take you forever if you did red and then waited 2 minutes and then did another spot of red and waited 2 minutes and then kept going like that for every color. So what I would suggest doing, the reason I would say to line all these up is because you can spot red, put it down, spot orange, put it down, spot yellow, put it down, and then go down the line. And by the time you make it back to red, it should be dry already. So then you would just keep going in order until you've done it 3 or 4 times. And then at that point, some of your spots may be darker than others, and then you can just pick and choose which ones you have to keep adding to. So once you've done spotting, you are now on step 3. It tells you to place 20 to 30 mils of 1% sodium chloride solution into a 600 ml beaker. You are only going to do 20 mils. As you can see in step 4, towards the latter part of it, it tells you to make sure that the initial solvent level is not above your pencil line where the spots are. This is why we only want you guys to use 20 mils, because if your solvent level is above or on that pencil line, then that solvent is just going to dissolve the dyes into solution rather than moving the spots up the paper. Okay, so only do 20 mils for this. Step 4 tells you to carefully staple your chromatography paper into a cylinder. It tells you not to let the edges of the paper overlap and to make sure that the paper is not touching the sides of the beaker. So this is what it will look like when you stapled it into a cylinder. I suggest that you and your partner work together to get this stapled. So one of you can hold it into kind of a cylinder, and then the other one can staple it from that end, and then you just turn it around. As you can see, I have a gap between my 2 edges. They're not touching and they're not on top of each other. So this would work perfectly. And the reason I have a third staple in the middle is because sometimes you will get a bubble, and that would be going against the part that says not to let your paper touch the sides of the beaker. If you happen to get any solvent on the side of the beaker when you pour it in, and that solvent touches that bubble in the paper, then the solvent will spread there as opposed to rising from the bottom. Okay. So even though we're only putting 20 mils of that solution in, make sure that you check to see that the solvent is not going to go, even with that pencil line or above that pencil line before it starts to run. Okay, so the last part of step 4 tells you to cover the beaker with parafilm. This is going to be what your parafilm looks like. All you're going to do to use this is peel off this part that has the logo on it, and you'll be left with the sheet. It's kind of got a waxy feel to it. You're going to hold it where your thumbs are flat, almost as if you're holding a tray. And then we're going to pull to the side, and you'll see it stretch. Okay, and then you're going to turn it in the other direction and grip those sides, and then pull it this way as well. You'll be surprised at how stretchy it gets. And then once you've got it stretched out, you'll place it on the beaker and then press it on the edges to seal. And the reason we use parafilm is to keep our solvent from evaporating. This part of letting the chromatography run in step 5 can take a little while. It might take, up to half an hour. So in that time, you guys can go ahead and start cleaning out your test tubes. I will go ahead and say, when you are cleaning out the chocolate left in the large test tubes, you may need to use your stirring rod, but just be sure that you don't leave that chocolate in the sink, okay? Get those out so that we don't have to go behind you and pick those up, and make sure you put those in the garbage. So again, back to step 5, you want that solvent to get close to 1.5 centimeters. We already talked about making those marks at the top, so you should definitely see when it gets there. And then it tells you to remove the paper and quickly mark the solvent front with a pencil Be careful because the paper is wet, and so a pencil could kind of tear into that. If you're having trouble knowing where to draw the line for your solvent front, so some people end up with a straight line. So if you can see the pink that's kind of towards the top, it's meant to be a straight line. Then you would just take your pencil and draw a straight line even with your solvent front. But for those of you who end up with a kind of curved and uneven solvent front, then I just want you to find the lowest part of that solvent front. So if this is mine that's uneven, this is my lowest part, and that's where I want you to draw your pencil line for your solvent front. Okay. And then it tells you to place your paper on a paper towel to dry, and then we can put it under a heat lamp to make it dry even faster so that we can find your spots sooner. Okay, and then the very last step tells you to calculate RF values for each spot on your chromatography paper. So that has a lot to do with number 1 on your data sheet. So you would expect 7 spots on your chromatography paper, and it's totally understandable. You have 6 M&Ms and their dyes, and you have tartrazine, which would be your 7th. However, if you remember back to kindergarten or 1st grade when you talked about mixing 2 colors and getting another color as a result, this is one of the hints that I'm going to give you guys. This is a similar case with a couple of our M&Ms. Our brown M&M has red and orange, and our green M&M has yellow and blue. So in addition to the 7 you had originally expected, you'll actually end up with 9 spots. So make sure that you find all 9 on your chromatography paper. Okay, and then when you're showing your calculations and your RF values on number 1 for your data sheet, make sure you distinguish between your colors that are duplicates. So if you've got red from the red M&M and then you've got red from the brown M&M, make sure you say which M&M that red came from so that we know what we're grading. So when you go to find your spots and you're calculating RF, let's just say that this is my blue spot, and of course it will not be this vibrant of a color, and this is not where blue is going to be, I can assure you. But this is just for example so you guys can see. You'll start out with a small spot that you put on there when you were spotting the pencil line, but once the solvent moves through, you'll actually end up with kind of a streak of color. So I would circle the entirety of that streak, and then I'm going to put a line through the center of that spot. When you are doing RF and you're measuring to the spot, you don't measure to the front or the bottom, and you don't measure to the top, you measure to the center of that spot. So I drew a line to help me be more accurate in my measurements. And so from my pencil line to the center of my spot, it was 5.3 centimeters. And then from my pencil line to the solvent front, it was 8.5 centimeters. So if you looked at the theory for this, you know that RF, or retention factor, is the distance that the spot traveled over the distance that the solvent travels. So if I wanted to calculate RF, I would just do 5.3 centimeters divided by 8.5 centimeters, and I would get my value. Another important note is that RF does not have units. Okay, centimeters divided by centimeters would cancel out. So don't put centimeters as your unit or centimeters squared. There are no units, it's just a number. Okay. So the other big question to answer is number 3 on your data sheet when we are asked which M&Ms are safe for our friend to eat. So when you're looking at your chromatography paper, remember that tartrazine is what we're comparing everything to. So any of our spots that have the same RF as tartrazine mean that our friend cannot eat that color. Any of the spots that have a different RF from tartrazine, then they are safe for our friend to eat. Okay, so just a quick review of the 3 big things for this lab. Don't leave your M&Ms in the sink. Do not move our hot plates because we would not want to blow the breakers in here. So if you don't have a hot plate at your bench, then please move to one. If you're not sure which one, then let us know and we'll point you to the right one. And make sure that when you are using your stirring rod to go between different colors or dyes, that you are rinsing it with distilled water in between. I believe that is everything. I hope this has helped you guys out a lot and that you are able to do lab a little bit more efficiently this week. And I hope you guys have a great week.